My name is Ledoux, and I am presenting on faculty-driven versus student-driven design projects for Mechatronics Engineering Capstone. I did this project in conjunction with my co-author, Brian Slaboch, who used to be at MTSU and is now at Milwaukee School of Engineering. What is mechatronics engineering? So y'all may be familiar with this graphic developed by Kevin Craig and later adopted by ASME. But basically, mechatronics is mechanical engineering, electrical engineering, computer programming, and controls, all combined into one major. This is a relatively newer major in the United States, and it's concentrated in the Mid-Eastern region. So there are 6 schools that offer 4-year bachelor's degree in mechatronics engineering that are ABET accredited, and these are listed here in order of accreditation year. I will focus on Middle Tennessee State University, MTSU, because that's where I teach. So what constitutes a mechatronics capstone project? Well, there are 2 categories, both major specific requirements and ABET student outcomes. These are the 7 ABET student outcomes for accrediting engineering programs, and it's commonly expected that senior capstone projects meet all of these or close to all of them. For a mechatronics engineering project specifically, then it must consist of mechanical system, electrical system, programming, and user interface. Because an industry project that encompasses all of these criteria is so often too complex for a team of undergraduates to do in 2 semesters, then industry-sponsored projects are not common. So the 2 methods that are common are faculty-driven and student-driven approaches. So we've used both of these at MTSU over the last decade, and so I'm going to go into each method and pros and cons of each. The faculty-driven approach is where the instructor scopes the project and assigns students to teams with no input from the students. For the student-driven approach, the students form teams themselves, and the students and instructor scope the project together. Both projects are either way, then the projects have to meet both the mechatronics criteria and the ABET student outcomes. Faculty-driven projects were the first kind used from 2016 to 2019, and my predecessor, Brian Slaboch, taught during these years. We had 1 year of overlap, and that was the 2018 to 19 school year. So in this approach, the faculty member scopes the projects and assigns the team. So uniform projects, meaning that the design constraints and the goal of the project are the same for every team, and each team has 4 students on it. This is meant to mimic a formal industry setting where the instructor acts as the customer. Students must submit formal requests for negotiations and change orders, etc., and schedule meetings with the instructor outside of class time in order to work on those. Projects are subject to scope changes and questioning by upper management, who could be the course instructor or other faculty. And extensive documentation and project management is required. Student-driven projects were used from 2019 and continuing into the present. And the move towards a student-driven project was motivated both by student feedback and by the growing program. So in this method, students and faculty collaborate to scope the projects. So the teams are made of 3 to 5 people, depending on the complexity of the project. And there is a large variety of projects. So these could be for competition teams, or they could just be things that the students have been dreaming about and finally wanted to make. This is meant to mimic a collaborative industry setting where the students themselves identify potential customers and a need for their product. And negotiations and scope changes can be discussed anytime, whether that is an informal laboratory setting or office hours, whatever. The projects are subject to questioning and technical advice by subject matter experts, but typically not scope changes. Extensive documentation and project management are required in this type of project as well. So this course takes students through the different phases of design from concept to delivery and marketing. Each white block here represents a designated class period or periods in order to help keep all of the students on track. Design is iterative, so we close the loop between the first and the second semester by prototyping the first semester and formalizing the product in the second. This is a more detailed course flow. So at MTSU, senior design is taught as a 2-semester course with specific milestones shown here. The first semester focuses on design, modeling, and prototyping. So by the midterm critical design review, students must have a detailed design done. By the final, they must have their design revised, completed, and all subsystems prototyped separately. The second semester focuses more on system integration, testing, and optimization. So by the factory acceptance test at midterm, they need to have all of their systems integrated together and functioning, not perfectly, but well enough to test. And then between the midterm and the final, they're testing and optimizing so that the system that they present on our MechTech Design Expo at the end is a fully optimized and beautiful looking system. The course is scheduled as 3 credit hours and 5 contact hours each semester, and this is in 2.5-hour blocks every week. So the hypothesis here is that both faculty-driven and student-driven projects can be successful, but there are pros and cons to each. Brian and I compared notes from teaching each type, and we will also have grade history and student survey results to show. We did this data collection through MTSU's IRB approval. The faculty-driven approach was largely successful. Most students have some initial resistance to being on a project and team they didn't choose, but throughout the semester, they become quite invested and most of them pass. Many projects have been highlighted by the university media, and one, a Yahtzee playing robot, is shown here. So this project has a mechanical system, it has an electrical system, it has a user interface, which you can't quite see, but it is over here. And then it also has programming in order to actually control the robot. So all students produce a full documentation package as well, with a design report, CAD drawings, wiring diagrams, assembly guide, user manual, a customer acceptance document, and a poster for the MechTech Expo at the end of the year. One caveat to this approach, apart from initial student resistance, is the potential for faculty bias. So the course is mostly taught by teaching-focused faculty without the potential for biasing in an area of research interest. The student-driven approach was also very successful. The students really enjoy choosing their own projects, and it eliminates the potential for instructor bias and adds variety. These projects have also been spotlighted by local media. So there is, the one shown here is a remote-controlled submersible. So you can see this one is taken apart, but you can see the interior components and the external hull. This ended up being watertight down to at least 3 meters. They tested in a swimming pool, and it was very successful. The students in this project area also produce a full documentation package, with the main difference from the faculty-driven approach being the absence of a customer acceptance document. Now, some challenges associated with this method are that because the students have more input on their design criteria, sometimes they forget to consult the instructor regarding changes of scope and quickly forge in a new direction. Because the difficulty of projects varies, the number of assigned students must correspond to that. And finally, because sometimes students plan to sign up for someone else's project on the first day of class, or they don't know many other students, or they've been blacklisted by other students, this often results in one team of leftovers who struggle a little bit more than the others to gel and progress. Course grades over the last 5 years are shown below. So most students do well with about a B+, A- average in the course, and the report average is a B, but that improves from the fall to the spring. The peer evaluation scores are also high, likely due to the students choosing their own teammates, although that does not always work in their favor. In this survey, students agreed or disagreed with how well the course addresses ABET student outcomes. You can see that pretty much 85% or more of students do agree that the course meets the ABET student outcomes, except for these two. So these are the parts of student outcomes 2 and 4 that deal with engineering in a global context. And I think that the reason these are lower is because although the course does require students to think about their project in the context of the world, a lot of times they get so focused on building a cool machine that they forget to actually do that. And so that indicates why these are probably a little bit lower. So that is an area to focus on for improvement. In this part of the survey, students self-evaluated their ability to meet each ABET student outcome. So the student outcomes are on the left and the average ratings are on the right as mean plus or minus standard deviation, where perfect is an 8 and terrible is a 0. Now you can see here all the ratings do fall in a reasonable like 7 to 9 range. Average ratings greater than 9 would indicate overconfidence, and average ratings less than 6 would indicate with a problem with the program. So these are all in a pretty good range. The lowest two here are oral and visual communication. And this makes sense because a lot of students struggle making or giving PowerPoint presentations. So this is another area for potential improvement. Most students see positive course impacts regarding important skills, improved learning, and instructor investment. So in conclusion, both faculty-driven and student-driven models can be successful, with projects meeting all ABET and Mechatronics requirements and most students earning A's and B's. Faculty investment is required, but the responsibilities vary depending on the approach used. The benefits of the faculty-driven projects are well-defined and achievable scope, as well as uniform project structure and expectations. The benefits of the student-driven method are strong student investment and autonomy, and creativity and variety is guaranteed. Thank you for listening. What questions do you have?